All right, welcome to the last part of our trigonometry unit. This is angles of elevation and depression, so this is more used when we're talking about story problems. So the first thing we're going to talk about is angle of elevation. So it's a line of sight upward. So for example, if you're standing in front of a building, you have to look up to see the top of the building. So it always works with a horizon line or a horizontal line when you're looking straight forward. And then what do you need to do to see whatever it is you're looking at? So if I have to look up, my line of sight travels to the top of the object. So since I have to look up, angle of elevation. So when you're looking at an angle, your horizontal line, so number one, this is my horizontal line. 2 is an angle, so that's my line of sight. Sorry, that's my angle of elevation. And part 3 is my line of sight. So the angle of elevation is always between the horizontal and basically the hypotenuse of a right triangle, because if I made a dotted line right here, I'd have a right triangle. So your angle of elevation is always between basically the adjacent and the hypotenuse. The angle of depression, think down. Again, we go from a horizon line or a horizontal line first. So if I was looking straight forward from an elevated position, I'd have to look down perhaps to see something on the ground. So my line of sight. And the angle between those is my angle of depression. And since it's going from the horizon down, that is an angle of depression. So you need to keep that in mind when you are using story problems to draw pictures. So in example 4, my angle is between the horizontal and the line of sight. Notice it's not up here. It's never between the vertical and the line of sight. Always has to be between the horizontal and sight. So again, the adjacent and the hypotenuse. So this would be an angle of elevation. In example 5, again, we mark the horizontal, and then I'm looking down, so my line of sight from the tower to the campfire. And since this angle is going down, I have to look down to see the campfire. That is an angle of depression. So angle of elevation from the horizontal looking up, angle of depression from the horizontal looking down. So let's try some examples of identifying. So let's mark our horizontal lines with a highlighter. Okay, and our lines of sight, like so. And we have one more horizontal. So if I'm at the level of the flock of birds and I'm looking down to the ship, between the horizontal looking down to get to the line of sight, that is angle of depression. Number 2, I'm standing on the ship, I'm looking up at the birds. So this would be angle of elevation. Number 3, standing on the ship looking down to see the submarine, angle of depression. And from the submarine looking up to the water surface, angle of elevation. Now, because these horizontal lines are parallel, the angles of elevation and depression are alternate interior angles, so they're always congruent. So if I draw a right triangle, I can always move angle 3 down to angle 4. I can always interchange these. These are equal. They're congruent. So for number 2, take a moment to try those problems, and we'll come back in a second with the answer. So now hopefully you have these 4 answers correct. And we can move on to similar trig problems. So problem number 3, this would be an angle of elevation. And again, we just set up the trigonometry problem like we're used to doing. So the x represents your opposite, the 250 your adjacent. So this would be the tangent ratio. Tangent of 25 equals x over 250. Cross multiply 250 times the tangent of 25 will equal x. Make sure your calculator is in degree mode. And you get approximately 117 feet if we round to the nearest whole foot. For the boy with the kite, this would be an angle of elevation problem. The x represents the adjacent. If we're looking at the kite string, that would represent the hypotenuse. So this would be cosine 32 degrees equals x over 100. So 100 times the cosine of 32 equals x. And you get about 80 feet. Would be the distance from the person to where the kite is. You could also find the height the kite was above the ground, but you'd have to be careful in this one because you'd also have to add in the person's height here. And if you look at some of the PowerPoint notes on the Weebly site, there are some examples where you'd have to add in a person's height. Okay, the next problem is angle of depression. Here's the horizontal. We're looking down to the hypotenuse. Now, if you don't like the 27 here, we can put it in its alternate interior angle position so we can make it look like an angle of elevation because those would be the same. So we can go with the 27 here, and you'd have opposite and hypotenuse. So the sine of 27 equals x over 580. So cross multiply 580 times the sine of 27 equals x. And you get about 263 yards. And that would represent a height. So again, angle of depression. You can move that inside the triangle. Angle of depression and elevation are congruent. So we have adjacent and opposite. So tangent of 18 equals opposite over adjacent. So x times the tangent of 18 equals 2. And remember, in this case, put the tangent of 18 in parentheses. Remember, that's one single number. So x would equal 2 divided by the tangent of 18. And it's about 6 kilometers. So that would be a ground distance. So this might be, you know, an airplane is coming in for a landing. It's 2 kilometers above the ground. It's coming in at an 18-degree angle. How far does it still have to travel to get to the runway? So we are going to try one of these problems together, and then you will be responsible for finishing problems 8 and 9. So drawing a picture, we have a person standing from a flagpole. So we'll draw our little person. 30 feet from a flagpole, so that means along the ground. So we have a flagpole here. Now that person's eye level is 5 feet from the ground. So we're going to have to take that into consideration when we're finished with the problem. We want to find the height of the flagpole to the nearest foot. So if from their eyes they look up to the top of the flagpole, the angle from the horizontal would be an angle of elevation. So we're looking up. And this is a 35-degree angle. And they're 30 feet away. And we want to find out the height of the flagpole. So for right now, our X will be from the top of the flagpole to a spot 5 feet above the ground first. So this 5-foot distance we're going to deal with at the end of the problem. This would also be 30 feet. So we have opposite and adjacent. So we have the tangent of 35 degrees equals X over 30. Multiply by 30. So 30 times the tangent of 35 is about 21 feet. But remember, that's not fully the length of the flagpole, so we have to add in 5 feet to get the whole flagpole. So 21 plus 5 equals 26 feet. So take a moment to finish problems 8 and 9, and we will reveal the answers.